നമസ്കാരം. കേരള ലിറ്ററേച്ചർ ഫെസ്റ്റിവലിലെ വളരെ വ്യത്യസ്തമായൊരു സെഷനിലേക്കാണ് നമ്മളിനി പോകുന്നത്. ഗണിതശാസ്ത്രത്തെക്കുറിച്ചുള്ള ഒരു സംവാദം, അതും കേരള സ്കൂൾ ഓഫ് മാത്തമാറ്റിക്സ് എന്ന് വിളിക്കപ്പെടുന്ന കേരളത്തിൻ്റെ ഗണിതശാസ്ത്രത്തിലുള്ള പാരമ്പര്യത്തെയും ചരിത്രത്തെയും കുറിച്ച് അതിനെ വളരെ സൂക്ഷ്മമായി പഠിക്കുകയും ആഗോളതലത്തിൽ വലിയ സംവാദങ്ങൾക്ക് തുടക്കം കുറിക്കുകയും ചെയ്ത മാഞ്ചസ്റ്റർ യൂണിവേഴ്സിറ്റിയിലെ എമിറേറ്റസ് പ്രൊഫസറായ ജോർജ് ഗീവർഗീസ് ജോസഫ് സാറാണെന്ന് നമ്മുടെ കൂടെയുള്ളത്. മലയാളികൾക്ക് അദ്ദേഹം എത്രത്തോളം പരിചിതനാണെന്ന് എനിക്ക് സംശയമുണ്ട്. കുറച്ചും കൂടെ നമ്മൾ അറിയേണ്ട ആളാണ്. കാരണം അത്ര ശ്രദ്ധേയമായിട്ടുള്ള സംഭാവനകളാണ് അദ്ദേഹം ഭാഷയ്ക്കും ഗണിതത്തിനും കേരളത്തിനും വേണ്ടി നൽകിയിട്ടുള്ളത്. വണക്കം, നമസ്കാരം.
Let me begin by saying that I am particularly happy to be here. As you'll probably gather as we talk, as the Fireside chat goes on, that the area that I'm going to be talking about is not very far from here. And what is astonishing to many people is that this is an area which produced one of the most brilliant episodes of mathematics, of which I will very briefly describe. I will not talk about the maths, because in a sense that's been covered quite a lot, and I'm aiming at a general audience. So I'll be talking about the sort of historical basis of the growth of this particular school of mathematics, and then also talking about some of the sort of philosophical implications of this maths coming as a sort of almost a separate entity when sort of compared to the modern or the Western mathematics.
Let me ask you the first question. The Kerala School of Mathematics, when we speak about Kerala School, there is a lot of confusion among the people to understand what is Kerala School. Could you please explain how you come to such an idea of Kerala School of Mathematics?
Now, the interesting thing about this particular school is that there is a number of terms that have been used to describe it. There is the Kerala mathematics, there is Madhava mathematics, there is the Madhava, as we will see soon, was in fact the founder of this particular school of mathematics. There is the late Aryabhata mathematics, because Aryabhata I was a main inspiration for this maths. There is the Nila mathematics, Nila standing for the particular area around the river where the maths was sort of first developed. There is medieval Indian mathematics, which probably the difficulty with that is it ignores certain other mathematical developments in the north of India. Each of these definitions has its own significance. Now, to be able to understand what a remarkable school this was, I want to point out that when you look at modern mathematics, there are two developments. One is the growth of and the development of infinite series, and the second is the creation and the development of the algorithms of calculus. A lot of you probably are familiar with the ideas of differentiation and integration. Now, the Kerala contribution was in the first area of infinite series, and that was almost the engine that drove the development of modern mathematics. So Kerala can actually claim to be the place where the modern mathematics was born, because after all, when we talked about modern mathematics, it's basically to do with calculus. And the infinite series was produced in Kerala about 250 years before it appeared, and the familiar names are Leibniz and Newton. So it's a very remarkable sort of development, which I hope more people in Kerala know about it, because a relatively small place like this created that maths.
Then how can we trace its genesis?
The origin of this particular school of mathematics, apart from the founder, which I'll talk about in a little while, came from one of the great Indian mathematicians called Aryabhata I. He was the one who was responsible for providing a couple of mathematics which the Kerala mathematicians took up and developed. One of it was to do with the calculation of the value of pi, the circumference over diameter, and the other one was the development of the idea of function, or the beginnings of the idea of function, which is a very important element in mathematics, modern mathematics.
Let me ask another question about another angle to this issue. How you got interest in this Kerala School of Mathematics?
I'm sorry, I didn't follow you.
How you got interest to this research area?
My interest in this area grew from after I had sort of done research and wrote a book called The Crest of the Peacock, Non-European Roots of Mathematics. The idea was that there was a whole lot of areas of mathematical developments which had taken place outside Europe, which was quite often neglected. So the Crest of the Peak was an attempt to highlight what the developments were. Now, when this book came out, one of the reviewers said, "Oh, that's all very well, but countries like India and others only developed very elementary mathematics." And it was my attempt to understand this and to try to do further research on that, which led me to the Kerala mathematics, because the Kerala mathematics by no means is elementary. It is in fact quite advanced. As I said before, it is the starter of the whole development of calculus. Calculus is often seen as the start of advanced mathematics. So I think that was what led me to it. And of course, I have taught in different parts of the world, and this question always arose about where did calculus originate? And it was something that I researched, and I read up things, and that sort of gave me the ideas.
How this Eurocentric discourse, or the people of these Eurocentric ideas respond to your findings?
Sorry, I didn't get that.
How the people of this Europe and America respond to your inventions?
Well, I think to begin with, the Crest of the Peacock actually laid the foundations for further questions and also further inquiries by the Western mathematicians, because the book itself soon became a very widely accepted book, and in a way that sort of provided the basis for my next area of research, which was on mathematics in Kerala. So on the whole, I found that the mathematics, particularly the mathematics that arose from the Kerala school, was accepted, but the general view was that that was a development that was independent of the development in the West. So I spent some time trying to see whether there was any connection between the developments in the West compared to that of India and specifically Kerala mathematics.
And who was Madhava? That's the next point.
Madhava is an incredible figure. He lived around the earlier 14th century, earlier period of the 14th century. We can't definitely date him. There have been all sorts of dates suggested for it. But the main thing about him is that one thing that scholars have agreed that he came from an area of what you call where the Tulu Brahmins came from originally. And he was part of that group of people who sort of migrated south and came. Now he was incredible in the sense that he never left anything that he wrote, but practically every one of his disciples talked about their particular discoveries as being something that could be attributed to Madhava. So Madhava is the true founder of this school, and the school incidentally lasted for about 200 to 250 years, almost at the eve of the discovery of calculus by Newton and Leibniz. So all of it is through attribution. I would compare him to Pythagoras. Pythagoras did not write anything. What you call Pythagorean theorem was something that somebody else attributed to him. Pythagoras, however, took on almost a mystical significance because of his work. The work that you're most familiar with is the Pythagorean theorem, which is to do with the triangle, a right-angled triangle, and the relationship between the hypotenuse and the other things. Now, so he was that. He was also, as far as we know, somebody who set up a school which lasted for a long time. To give you some example, Madhava was in fact the teacher of Parmeswara. Parmeswara in turn taught his son Damodara. Damodara in turn taught his disciples Nilakanta and Jastadeva. And that sort of teacher-pupil relationship goes right down further. By about the 17th century, though books were still being produced, there was nothing or very little that was original about it. The book that we know now is Sankara Varman, which was sort of produced around the early decades of the 19th century.
What is the importance of such contributions in an international sphere, Madhavas?
Well, I think to explain the importance, let me say, one of the things that gave me a lot of satisfaction, because I can claim part of the credit for it, is that a number of results which are usually named after Western mathematicians or European mathematicians was in more recent books always have the name Madhava. For instance, there is a Madhava Gregory series for the inverse tangent. There is a Madhava Newton series for the sine series. There is the Madhava Madhava Leibniz series, and so on. So in a way, the Kerala mathematicians' contributions are now being quite correctly recognized. And to tell you just a little story about this, after I talked about it and we had a discussion about it, a number of people came around, not a number of people, a few what I would call as mathematics tourists came around looking for where some plaque or looking for some place which could be associated with Madhava. They didn't find anything and they were very thing. Now if you look at Newton was born in Gresham. The thing is filled with a number of souvenir shops, also a number of places named after Newton. It's a source of great surprise, and I'm very sorry about it, that one of the greatest mathematicians of this country has not been recognized sufficiently when his contribution was quite phenomenal.
His Crest of the Peacock was published by Princeton University, the most important university.
It's got a long history, some history of publication. It was first accepted by Penguin London. Before they published it, they thought they would bring up the hardback copy, which was done by another publisher, for 2 years. Penguin, in turn, sold the rights to partly to the Indian Penguin, Indian one of these East-West publishers, and they also sold it finally to Princeton University Press, which, as you say, is very prestigious. It makes a big difference where you publish a book, and Princeton was there. Now it's gone through 3 editions, 6 reprints, and 4 translations into different languages. So it has been considered one of the classics. And the present one, which I hope will be translated into Malayalam, is a 3rd edition, and I've completely altered it to take account of some of the most recent research.
Let us come to Yukti Bhasha.
Sorry?
Yukti Bhasha.
Yeah.
Yeah. The first mathematical text in Malayalam.
Yeah.
Could you please explain its origin and the significance?
You see, one of the very interesting things about the texts of the Kerala mathematicians was that the earlier texts that were published were actually all in Sanskrit. Now, the Yukti Bhasha, which is the one by Jastadeva, partly because a lot of people didn't understand old Malayalam and because they were hung up on Sanskrit, found that they tended to neglect Yukti Bhasha. Incidentally, only relatively recently has a translation come of the Yukti Bhasha into English. Now, the question, a very interesting question is, why was it published in Malayalam? And I'm told, I don't know enough about the language, but I've been told that the Malayalam of it is very colloquial Malayalam. It's not the classics language. Why did it arise? And why, for instance, was this a text where it was, though there was a second part, the Yukti Bhasha, which was to do with astronomy, the most important part was the first part, which was all mathematics. One of the very few texts where in the Kerala mathematics, as far as I know, the only one where The text is in Malayalam, and again, very rough Malayalam. So the question then, a very intriguing question comes. Who was it published? Oh, I should say about the Yukti Bhasha, it is the best text now in relating to Kerala mathematics. It's got proofs, it's got definitions, it's got some wonderful illustrations, very down-to-earth illustrations, and all that. The question is, why, when the usual thing is for things to be published in Sanskrit, was it published in Malayalam, though the technical terms were all in Sanskrit? Now that's a very interesting question. So somebody has recently described Yukti Bhasha as the first textbook in calculus because it's rigorous, it doesn't make any assumptions about any of the about any of these results. Each of it is proved, either proved or shown to be proved. And it is better than later later textbooks that have come, including Makari. Sorry, I got the thing mixed up. And it is also something that needs further investigations. The text itself has quite a strange history because, as I mentioned before, because of the fact that it was in fairly oldish thing, people didn't bother about it. But now there is a translation of it by K.V. Sarma, one of the great scholars who has actually brought Kerala mathematics into the open. Also, there has been a very recent translation, not translation alone, but a commentary on the translation by Srinivas, Ramakrishnan, and Sri Ram. I would recommend that you have a look at it. It's very well done. It's a commentary, meaning that is put in modern terms.
Could you please explain the difference between the approaches in mathematics, Indian and Western? Is there any change in the methodology?
I think one of the basic things, I think this is itself is quite a broad subject, but let me just point out one difference. The Indian mathematics, and that includes not just the Kerala mathematics, but earlier mathematics as well, they in fact the mathematics was sort of based on different sets of principles compared to the Western mathematics. Western mathematics always saw proof as being primarily concerned with that sort of deductive axiomatic method of proof, that you start with a set of premises and then, or set of axioms, and then you go on to prove that these axioms hold good under certain premises. Now, the Indian mathematics was much more pragmatic in its approach. It tended to sort of see it in terms of whether a proof satisfies a learned group of people, that would be fine. That means that's perfectly acceptable. It also meant that they used not deductive so much as empirical methods of proof. But when people reject this and say that it's an inferior form of proof, I always think about the fact that there aren't any significant examples of anything that has been proved being found to be wrong. In other words, let me mention one of my favorite persons, Srinivas Ramanujan. As you know, that he produced a whole set of results, remarkable results. He never produced the proof in the sort of Western sense at all. But yet, it's been found that out of over 1,000 things in the lost notebook, that's a notebook that he wrote during his last year of life, among the proofs, just 2% of it is wrong. The rest of it, the statement is there, and people have spent now many decades trying to prove them, and only 2% is found wrong. So here is a case of what I say, the use of the Indian method of analysis being as good as the deductive axiomatic. Anyway, Newton never used the axiomatic method. He used a pragmatic empirical method.
Yeah. Do you find any difficulty to convince the European mathematicians about the validity of our Kerala mathematics or Indian mathematics or the non-European style of mathematics?
Well, I think, talking specifically at Kerala mathematics, it is interesting. One of the things I recently discovered was about an article that was written around the 1830s by somebody called Charles Wish, who in fact went on to actually report the incredible mathematics found in some of the Kerala texts. Charles Wish, I would put him in the similar category as K.V. Sarma. But the point was that when his results came out, it was dismissed, not by the general mathematicians, but this was during the time of the East India Company. They dismissed it as saying that the whole thing is fraudulent. And it took 10 years for Wish to publish it in the Royal Asiatic Society Journal, but it was never accepted. So I have a feeling that there is also a type of Eurocentrism in the way that some of the earlier mathematics of India was looked at. I'm not saying it exists now. In fact, I find some of the Western scholars much more open than some of the Indian scholars. But I think, so one is the Eurocentrism. The second is their great reverence for anything Greek. So that's the second thing. I think the third thing is some claims that have been made for Indian mathematics for which there is no evidence at all.
Like to have some more.
Thank you. Thanks very much. But there are also other reasons as well. I think possibly the fact that the Indian mathematics was so localized, I'm talking about the Kerala mathematics, and there wasn't sufficient attempt at disseminating some of this mathematics. That was a problem that comes. I think that would be, in fact, some of the reasons.
In India nowadays, there is a lot of debates are going on about the heritage of the knowledge, science, everything in India. Normally, people used to connect it with mythology and take it as science. But Kerala school is an entirely different thing. It's a pure science, mathematical science. How do you see the current trend in Indian approach? Will it affect the credibility of our earlier inventions in mathematics or in other areas of science?
I think nowadays, basically, there is only one universal way of doing maths. Unfortunately, in some ways, while this is a great strength of it, some of the sort of maths and some of the other types of local knowledge have been pushed aside. I mean, this is certainly things in like Ayurveda and a whole lot of other areas. But I would sort of say that in case of the Kerala mathematics, it did not have much of a practical value. The picture I have of Kerala mathematicians are a group of people sitting and delighting in mathematics, enjoying maths, what we would call as pure mathematics now. And I can sort of imagine somebody like Hardy, one of the great, who worked with Ramanujan, one of the great pure mathematicians, saying that Madhava, well, this is a bit of a stretch of imagination, saying that I have never done anything useful in my life. I've been doing pure mathematics. And I can quite see that happening. It was pure mathematics. There is an attempt to suggest that the Indians only did maths mostly for astronomical purpose. I don't think that's true as far as the Kerala mathematicians go. And this is what it makes it in a way very unusual. Because a lot of the earlier people like Aryabhata, Bhaskara 1, even Bhaskara 2, and even further, they were all mathematicians who were also interested or were astronomers. So that's what makes it fascinating, I think, the study. Incidentally, the Indian method of approach, or rather the Kerala method of approach, has been tried out in a number of places in teaching calculus. And there are some distinct advantages of approaching it the Kerala way, approaching the infinite series in the Kerala way. So it may be providing a form of alternative to things. But I don't want to stretch this too far because our maths is now universal.
Now in India, there is a discussion about, always a discussion about Vedic mathematics, connecting with Vedas, and we have the tradition of maths right from the period of Vedas. And normally there is no substantial evidence to support it.
Yeah.
How you see that phenomenon?
Well, I mean, there is a thing like Vedic mathematics, and of which the most substantial bit, not that there aren't others as well, is to do with the Sulba Sutras. The Sulba Sutras were things which were used to design altars and came across all sorts of interesting problems like the square root of 2 being an irrational number, that is, never getting an exact value for it, or the pi being an exact value. There were some mathematical theories coming out of it. But what one sees as Vedic mathematics in another sense is, in my view, basically something that is neither Vedic nor mathematics.
Yes, yes.
Okay.
The current research in Kerala School of Mathematics, can you explain?
You mean the current research?
Yeah. In the area of Kerala School of Mathematics. I'm not meant the historical research, but the mathematical research, theoretical research. Is anything going anywhere like that?
I think the theoretical or the research and everything seems to be trying to study more and more texts. Now, some of it have been studied previously, but are being looked at again because the people concerned were good Sanskrit scholars, from what I gather, but not much knowledgeable in mathematics. So there are people studying that, and in a sense, I think basically the attempt at sort of just studying texts, in my view, has gone too far. What you should be looking at is comparative perspectives. That's the question you asked about different ways of proving. About also the social economic context in which the Kerala mathematics occurred. A very interesting question, and nobody has found a correct, full answer to it, is why did the Kerala School of Mathematics decline? Why did it go? I think this is a more a sociological, historical study, and something that would be of interest to people. Now, all sorts of reasons are suggested, but there remain reasons or there's theories. One is the fact that it was confined to a narrow caste. Another reason that is given is that the foreigners, particularly the Portuguese, came and caused considerable disruption. A third reason is that I've come across, I'm only mentioning ones which has some convincing bits about it. But the third one is that the link between the Kanyans, the astrologers, and astronomy, which was very alive and at one time declined. I don't know, I think this needs study by a good sociologist looking at it. Now, having talked about the caste system, do remember that the Kerala, though I didn't give the names of all of them, but the Kerala school, as far as we know, has as a founder a Tulu Brahmin, not a Nambudiri Brahmin. A lot of people say Nambudiri, that's not true. Has a number of Ambalavasis, which means that it was not just confined to the Nambudiri Brahmins. It sort of suggested a fluidity and a form of contact which you don't normally associate with probably other areas of learning. So I think that is the area where I think there's a lot of research done. Because in my view, we have reached a point at which we have enough primary material. There isn't any new discoveries to be made, as far as I know. I may be proved very wrong, but from my reading, there is nothing of that sort. So it's that. But I think we should also aim at, and this is meant for the students of both schools and universities, we should aim at using this knowledge to sort of increase the enthusiasm of the students and children and make them feel that not only, it's not a question of self-esteem, but it's different ways of approaching it. And my view is that that has sort of, in a way, fallen on the wayside because people are all the time concerned with passing exams, going through drills, and all that. I'm suggesting that follow one of the great things of Ramanujan, which is that you do the subject because you love it. Not everybody can love it, but I hope more people love it.
What suggestions you can give about forming a Kerala School of Mathematics as a part of some university or a special entity as it is in Kerala? And continuing the researches.
Yeah, I think that would be a very good idea. There was a move at one time in trying to do something at QSAT in Kochi, where not only was it an attempt to inspire some of the brighter students and school children, but it was also the attempt to sort of study the mathematical content of the Kerala school. I don't think that's taken place. I'm told that there is a place here called Kerala School of Mathematics and Astronomy, but I don't think that's historical. They're not concerned with the historical thing as far as I know.
And recently, one Indian is half Malayali named Manchul Bhargava. He got field medal in mathematics 3 years back. It's a great achievement for an Indian to get field medal, which is almost equal to Nobel as far as mathematics
Yeah.
research is concerned. His father is from Kerala, Payyanur. Such trends are coming in the mathematical research
Yeah.
from India and Kerala. How you see the new changes in the area of mathematical research in international perspective?
One thing I noticed is this is living in Britain. There is almost a feeling among the natives of the country that the Indians have a special ability when it comes to mathematics. That they are the ones who are able to deal with things in a. Now, there might have been some element of truth earlier because there was a greater emphasis placed on numeracy and calculations. But that is sort of dying. And one of the very worrying aspects about maths now, particularly at the school level, is what I describe as a math phobia, a development of a dislike for maths, simply partly because of the way that the maths curriculum is structured, partly because of the way that is taught, and partly because of the way that it is not recognized. That is, I mean, research mathematicians are not seen as being very particularly a lucrative job. So some of the best mathematicians that I've come across, at least in my limited experience here, are people who do maths and then go and do an MBA. Now, I'm not being prejudiced about MBA, but I'm just suggesting that if you got a good theoretical mathematician, I think his or her contribution would be particularly valuable because, I mean, take Ramanujan as an example, because some of his work only came into fruition, the usefulness of it came to fruition only many years after he died. So, need for theoretical research and sort of thing. But this has to be directed by some people who can inspire and teach in a way that would make people want to do more mathematics.
You were an advisor for the education ministry of Tanzania and some other African countries.
Well,
What is the way to overcome this maths phobia?
the math phobia, I think, develops partly because in a very contrary way, when maths is seen as not as an adventure. Mathematics is seen as something which is away from people, very remote. And a lot of people, children, quite rightly ask the question, what is the use of all this? And particularly given also in the society where it's sort of felt that somebody who does mathematics alone, apart from being very clever and maybe getting occasionally jobs in IT, are sort of fairly useless members of the community. So I think we need to change that. And I'm particularly sorry about India because India had a great reserve of untapped talent, which I feel that going at least as shown by math phobia.
This last point when we are coming to our discussion, this fake history.
Sorry?
This fake history you told, no? History, how got manipulated.
Yes, I think this is a controversial point. This is my own opinion. I'm suggesting, for instance, that I'll give you an example. That's the best way to show. One of the things I've not talked about is the possibility of transmission of mathematics. Mathematics doesn't know any boundaries. It can sort of spread all over given the right impetus, given the right set of people. Now, some years ago, we devised a research project which was being funded by a research organization in the UK, where the question that we were trying to examine is whether some of the ideas in Kerala mathematics went from Kerala to Europe and in turn sort of fed into some of the mathematicians in Kerala, in Europe, fed into their thing. Now, as a part of this sort of thing, we went and we applied and we were very, very successful in getting funds to go and look at some of the papers. But we concentrated on the Jesuits. Now, for the reason that the Jesuits at that time were among some of the most knowledgeable in mathematics, navigation, astronomy, and so on. They were specially chosen for that, and there were some of the courses that was on offer were courses relating to that. So our assumption, you can call it the assumption was that the Jesuits may have taken some of the ideas of infinite series from Kerala to Europe, not necessarily England, but to Europe. And the European mathematicians used that to develop their sort of mathematical theories. So we went through 4 or 5 sources of Jesuit material, archives, one in Rome, another one in Leiden, a third one in Coimbra, and a couple of others, and searched through those archives to come across any evidence. By the way, I should have said that there were strong motivational factors, because these Jesuits had been told by their superiors, look out for any new information on mathematics, on navigation, everything from the countries they went to. Partly India, of which Kerala was important, and also for China. Now, so we went through a lot of the material. In fact, we got 4 researchers working on it, and we found that there were strong factors which explain the motivation, the opportunity, because some of the Jesuits were in the court of the Rajas in Cochin, and the Cochin Rajas were quite well informed about things. But then what happened was we didn't find any direct evidence. We did not find evidence which said, any document which showed that there was a move of information from the Jesuits, information from the Kerala to the Jesuits, or the Jesuits went to Europe. So it meant that we had to make a conclusion that there were strong motivational and other factors, opportunities, but there were no direct evidence.
How do you see the influence of Arabs in Kerala School of Mathematics?
Sorry?
Is there anything like that? Yeah. Influence of Arab.
Yeah. Okay, the other sort of influences that we could have thought of would have been, apart from yours on Itikora, which is a very interesting thesis. The other thing would have been, we did put up a research project for whether some of the Arab mathematicians, ideas from theirs, would have come to Kerala. There were two Arab mathematicians or Islamic mathematicians who were important. One of them was Al-Tusi, who worked around the same time, and the other was Ibn Haytham. We looked at, now we haven't looked at it, but the interesting thing is to study. I was told that there was quite a lot of records available in Ponani Mosque or something. I may be pronouncing it wrongly, but that. Now, this is something left for people to have a look at it. So maybe the Islamic thing, but it is of limited use because even if it was, at no point did the Islamic mathematics ever develop to the extent of the Kerala mathematicians. Now, that is the only source that you can think of which would do. But if you could, I could just continue with that story, just to show about the fake thing. This was about 3 or 4 years ago. The Manchester University we submitted a report to the Manchester University saying that this was the result of our studies and our examination, and basically we said that there was no evidence for what we were hoping to find. But that is very important, that you always use the falsification principle. That is, you assume that your theory is wrong unless there is a lot of evidence.
Yeah.
Now, just a few months ago, I got a letter from one of the university authority things saying that there had been a blog in which they had the blog had said that we had claimed as part of the Manchester that Newton had stolen the laws of gravity from the Kerala people. This is what I call as fake, totally fake. Not only that, that put me in a bit of an awkward thing because I had to show that this was a thing. So a lot of the type of theories, not just in mathematics, but in certain other areas as well, has to be critically examined. And I think there was a famous philosopher called Karl Popper who said, use the falsification principle. When you feel that the theory is grabbing you, assume that is false, and then see whether there is evidence to suggest that. Now, I think that is not exact. Now, if I remember, you say, in your case, poetic license. He was writing a story, right? No. But that is different from fake
Claims.
result.
Yeah. Another thing I want a clarification from you, the influence of Buddhism in Kerala School of Mathematics.
In Kerala itself, I think the influence of Buddhism,
Because Buddhist mathematics
yeah,
as a branch is so developed.
I would say that the Buddhist thing influence is a wider Indian influence. You know that one of the great things of the Buddha's thing was the idea of shunya,
Yeah.
zero,
Yeah.
shunyata, empty your minds. Now, I've written a couple of articles, including ones in, I should have showed you this book, but the recent book on Indian mathematics that I've just brought out, this one, this particular one, in which I show that there's an interesting question, and the Buddhists play some part in it. Why, for instance, did zero as a number make its first appearance in India? You see, zero has a lot of things. Zero could be a magnitude, saying that there's nothing. Zero could be a indicator of some sort of point between negative and positive, between below sea level and above sea level. Zero could be a placeholder, which basically means that you use zero to hold the place. Zero could be three or four things. But one of the great contributions of the Indians was, and of which the Buddhists played an early important part, was zero as a number. Just as you can sort of multiply ordinary numbers 5 by 2, you could multiply 0 by 6. Now, therefore, zero made an appearance not only as a symbol, but also as a number. Now, the contribution of the Buddhists, particularly in imagining the idea of zero, thinking of zero, the earlier sort of philosophical basis of things, probably did have that's all I can say, probably did have a influence on the emergence of zero. You know, one of the things that I've shown in this book is that people have always said to me, what have the Indians done? They invented nothing, you know. Right. I would say that now Indians have invented nothing and infinity, because the Kerala work was on infinity. The Kerala work, or for that matter, the Jains, since you mentioned about the influence, the Jains had a very powerful influence on the emergence of infinity. So the Indians have invented both zero and infinity.
The Kerala school for 250 years, from 14th century or 15th century, then there's a lot of gap in between, nearly 500 years. How can...
There is a gap before the Kerala school between, I mean, the first phases of the entrance of mathematics that we know of into Kerala, mathematics and astronomy, I should put them together, was actually the work of Sankara Narayanan, who was an astronomer, and the work of Govinda Swami, who was also. But then there is a 500-year gap before the emergence of Madhava. And then suddenly the creative impulse in the Madhava thing seems to dry. So I would think that it is part of the whole thing. That's what I've tried to show in the Indian mathematics book. There are areas for which we don't have just a blank. It doesn't mean that you can't fill it. You may be able to fill it in the future, but there are blanks. For instance, there is a blank that comes in between the Sulba Sutras in Indian thing and the emergence of the classical Indian mathematics of Aryabhata. Why is there a... But it's very difficult to, given the nature of India, the sheer vastness of India and all these things being localized, you don't know how it's happening.
Now, let us have some questions from the audience.
ഒരറിയിപ്പുണ്ട്. ഈ വേദിയിൽ നടക്കാനിരുന്ന ഞാനൊരു കഥ പറയാം എന്ന സെഷൻ വേദി 2 അക്ഷരത്തിൽ 7:30 ആരംഭിക്കുന്നതാണ്.
Hello. I have 3 questions. First one, I'll start from the maths phobia. That is, I know that it's a research institute. So, is there any plan or is there anything that is already conducting for the school children, that is to get away from this maths phobia, that is to make mathematics more interesting? Okay. And the second question is,
Can you hear me?
yeah.
Well, basically there are plans for catering for the very bright kids. There are this maths Olympiad and a lot of other things being run. But maths for the average and less than average children, there isn't. Part of it is to do with it's a social reason, because in a sense, the way maths is taught, the importance of tutorials, importance of satisfying a particular syllabus works. And of course, the size of the classes. All these are factors too. I think it's very difficult to deal with this, but I think one way is if we can think of when children do maths, and I'm talking about primary school children, there are points at which they are turned off maths. Very few are turned off maths from adding, or sort of. Some of them are quite happy with multiplication as long as you see it as repeated addition. But the minute that you get the place value idea, that is the starting point of a lot of people being left out. Now, the other thing is also address this issue of children who feel that they are no good at that. Now, one experiment that we tried out in Manchester was particularly with children who are classified as being below average, that anything that they produced we said was correct. So if they multiplied 8 by 5 and they found it to be 42, we say right. Now, try to get them to think about, you have to do the thinking first. How can it be why does the child think it is 42? It's a very interesting question. Why does it? And you always try to take the perspective of children and give them the idea that you don't make mistakes, except that sometimes your reasoning may not be quite what it is. I think we are, all of us get very turned off at the stage when we are told that that is wrong and a big cross is put there. Instead, why do you put cross? Instead of a cross, put even an exclamation mark, almost to suggest that that was a brilliant answer. But this doesn't deal with the problem. I think it's the teacher's attitude and also the teacher's training. I don't know how it is in India. In Britain, it's very difficult to get teachers who have had some training. So they lack confidence. When they lack confidence, they get impatient when you ask them questions. Sorry. Your second question.
No, I'll ask third question first because it is related to your answer. That is, it was about the super kids. That is, who are very good in mathematics. Yeah. That is, finding such brains from schools. So you were already answered. That is, you are planning to conduct something like Maths Olympiad or something. So there may be kids who are very good brains in mathematics. At the same time, they are very low in language or etc. Okay. So you already answered that you are planning something like Maths Olympiad or something. So it's very good to give some kind of exposure for such kind of kids. Okay. In our system, current educational system says that if they are equal in all the subjects, they are very good. But they should see that if they are good in mathematics, then also they can be better in that itself.
Yes, I think, as you say, it's the way you approach it. But also, you have to be very sensitive about how you distinguish between the really brainy people in maths and the rest of them. The other should not feel that they are in some way.
That is, they can't communicate in better way, but they can solve mathematical problems
Yeah.
very fastly and so.
Oh, absolutely. This is sometimes, you probably heard of the case of, again, I keep on using Ramanujan because he's one of my great inspirers. You see, a teacher was teaching how anything divided by the same thing will always one. So he pointed out if you had five eggs and you divided among 5 people, each got 1, etc., etc. And he carried on this for some time. And then Ramanujan, who was at about 7 or 8, according to the report of a friend of his, sort of said, but what about if it is 0 divided by 0? What is it? And the teacher was totally flummoxed because the answer is not 0, by the way. It is undefined. You can't define it. How do you divide anything that by 0? It doesn't make sense. So I think you should be in a position to deal with, or probably even tell the student, look, I don't know the answer, I will check it out. One of the beauties about maths conferences I find is that you are producing a proof, detailed proof, as part of your contribution to a paper. And suddenly you feel that you're stuck, or somebody points out there is something wrong in you. You don't try to justify yourself. You say, sorry, I'll come back later, and look through it. Now that's an idea that I think the children should be also encouraged to do. Come back when I have reached a point of better understanding. That is.
So my final question, that is, I'm basically a computer scientist. So while my research, I had some discussion with my, that is, I need some clarification from mathematics people. So I know that maths is based for many other subjects also. So is there any work of collaboration there for the other stream of subjects, just like science, computers, or electrical engineers or so? Is there any work of collaboration at KSM, Kerala School of Mathematics?
I'm sorry, I don't know any at all. Sorry.
You mentioned something about the infinite series in Kerala School of Mathematics. In Kerala School of Mathematics, you mentioned about a particular infinite series. I too have heard about that. Could you please connect it to the calendar mathematics, the modern calendar mathematics?
Yeah.
I mean, is there any contribution from the part of Kerala School of Mathematics into the modern calendar mathematics?
Sorry, I didn't get that word.
Calendar.
Oh, calendar.
Calendar mathematics.
I see. I haven't come across anything that I know of.
Yeah.
Do you have some idea?
Yeah. I have seen certain papers, like a paper by one Mr. Raju. You also may have come across that paper. One Mr. Raju.
Yeah.
I think he's from some university in US.
Yeah.
He was connecting the Kerala School of Mathematics infinite series.
Yeah.
In fact, the infinite series Ka plus, I mean, the same thing, same infinite series you've been mentioning about. The same thing used to reduce the error factors in the solar calendar, which contributed a lot to the modern calendar that we are using right now.
I see.
Yeah.
Please let me have a look at it. I know Raju, and I've had a few arguments with him about things, but I mean, I don't know about the calendar.
I see.
Yes. But let me know details of it.
Yeah.
And I'll sort of follow it up.
Yeah. What I know, my knowledge is very limited in that particular area. But then what I know is, it's basically used to reduce the error factor in the solar calendar.
Yeah, but that's very much part of the Kerala mathematics,
Yeah.
where you are trying to reduce the error factors.
Yeah.
And not only that, you are also helping towards convergence of
Exactly,
students.
exactly.
The convergence is the sort of element.
Yeah.
And you can do it either by adding something
Or subtracting. yeah.
or subtracting, or subtracting between two particular expressions to
Yeah.
get that. Now, the person who did that very well was you'll find it very in great detail in Yukti Bhasha.
Yeah.
But that is actually done by this
Neelakantha Somayaji?
Neelakantha
Yes.
Somayaji. He after having praised Yukti Bhasha, I should say Neelakantha Somayaji is sort of quite an original mind, you know. And the fact that he could relate it to astronomy made it even more powerful, I think. But he had a number of these error factors, you know,
Yeah.
a number of them.
And which later used by European, Italian mathematicians to reduce error in navigational calculations also.
That's Nunes.
Yeah.
Nunes did it.
You have already mentioned about it.
I know. Nunes did it.
Yeah.
And we did study Nunes. The interesting question was whether Nunes got this information from the Kerala mathematicians. We don't know. I mean, there is a remarkable similarity between the two, but
I see. Now, another question is, what is the present status of mathematical linguistics from the point of view of a mathematician, not from the point of view of a linguist?
Yeah.
Because I know their point of view, but what's your perception about mathematical linguistics? My question is in the context of Noam Chomsky's regular grammar, context-sensitive grammar, context-free grammar, sort of thing. What is the present status of mathematical linguistics?
no, your guess is as good as mine. I'm sorry.
I see.
I don't know.
But that's growing, right?
Yeah. Well, I mean, certainly, as you rightly pointed out, the Chomsky's started a set of mathematical explorations, which was going very well until he got caught up in the politics.
Yeah, exactly. Yeah, that's particularly why I'm asking, is it developing or not?
Yeah. But I shouldn't be. I mean, Chomsky is a great
Great man.
but he, some people feel he would have been better off doing more work in linguistics. You know.
Exactly. Thank you very much.
So thank you very much. A nice evening and light. Thank you very much. Thank you.
Very hearty thanks to you, Mr. T.D. Ramakrishnan and Dr. George Gheevarghese, for your valuable presence. Now I invite Program Committee Joint Convener Preman Taravattathil to hand over the gift as a token of love and gratitude. I also invite the guest to receive the gift.
ഈ വേദിയിലെ അവസാനത്തെ സെഷൻ ആരംഭിക്കുകയാണ്. മലയാളം കാർട്ടൂണിന് 100 വയസ്സ്. പ്രമുഖ കാർട്ടൂണിസ്റ്റുകളുടെ സംവാദമാണ്. സംവാദത്തിൽ പങ്കെടുക്കുന്നത് ടി കെ സുജിത്ത്, കേരള കൗമുദിയിൽ കാർട്ടൂണിസ്റ്റായി പ്രവർത്തിക്കുന്നു.